Greetings, M squared here, and today we are going to talk about conditionals. And conditionals are a certain type of statement that we will use a lot in geometry. So first of all, I'm just going to go through a few pages of the notes just in case you might have missed the notes from class. And this little word bank over here is going to help us fill in these blanks. So it says, most of the time you focus on a sentence content. Most of the time when you read, you're going to focus on the sentence content. That's just what we're used to doing. But in the study of logic, it's more about the sentence structure than it is about the content. That's really important, and that can tell us whether it's true or false. And the way a sentence is structured determines if the sentence is true or false. Kind of a little weird. You're not used to that. So this is what we are going to talk about. So kind of got to wrap your mind around that. Okay, so we're going to talk about conditionals, but first we have to see what a statement is. So a statement is a declarative sentence, and either the statement is true or false. So write those in. So look at these sentences and decide whether they're statements. So if it's a statement, you can say for sure whether it's true or false. It is cold outside today. Could we say that that was true or false? Yeah. If it's 100 degrees, it's definitely false, right? If it's -20, it's definitely cold. So we're going to say, yes, this is a statement because it's true. Will you go to the movies with me? That's not true or false. So that is not a statement. Find your missing socks. That's not true or false. So it's not a statement. I'm going to France if I can earn enough money. Well, that could be true or false. Definitely. All pigs can fly. Well, that's false. So it's a statement. If 3x plus 17 equals 29, then x equals 4. Well, we can definitely tell if that's true or false. We could plug the 4 in and tell if it's true, or if it didn't work, we would know it's false. So I believe in this case it's true because 4 times 3 is 12. 12 plus 17 is 29. Okay, so that's what a statement is. So I want you to look at this right here. And in class, we talked about it a little bit. You can talk about it with you talked about it with your partner. I am lying to you. Is that statement true or false? What do you think? Well, there's just a couple options, right? If I am lying to you, then I'm telling you the truth. But if I am not lying to you, then I'm telling the falsehood. It's kind of weird. So this is called a paradox, where it could go either way. That kind of statement could go either way. It could be true or it could be false. We're really not sure. It could be interpreted a number of ways, But a logical statement is clearly one way or the other. It is either true or it is false. Well, most of the time in math, we are going to use logical statements, not logical paradoxes. So you should be able to tell whether it's true or false based on the evidence that you are given. So we're going to say statements. All righty, turn that page. So a conditional, now we're ready to talk about conditional statements. We've already talked about statements, but now we're going to talk about conditional statements. So remember, a statement is definitely true or false. Conditional statements have two parts. They have a hypothesis and a conclusion. And usually they are in the form of an if-then statement, but not always. In the proofs, in the theorems that we learn, most of the time it's going to be an if-then statement. So conditional statements can be threats. If you don't clean your room, then you are grounded. That's a conditional statement. As a threat, a conditional statement can also be a promise. If you clean your room, then I will take you out to eat. Those are both if-then statements. If you do this, something will happen. Here is another example. If an animal is a dog, then it is a mammal. Okay, so we have a hypothesis. The hypothesis part comes after the if. It's the thing that has to happen in order for the next thing to be true. Okay, and we're saying that if this is true, then this is automatically true. Now, sometimes we have conditionals where that's not the case, and then that's how we know that they're false. But we say that this one implies this one, right? If you know this, then you can assume this. The conclusion can be reached if we know that. So here's our little dog, little kind of Venn diagram. The dog would be inside because you have a whole bunch of mammals, right? And dogs are just part of that group. But if it's a dog, it's in the mammal category because all of this category is inside that bigger mammal category. So when you look up here, I want you to notice these variables, the P and the Q. The P was the one that went with the hypothesis, and the Q was the one that went with the conclusion. Now, that isn't always the case. You can use other letters, but in this case, it was a P and a Q. And when you see this symbolic form, this is a shortcut in math. So a lot of times we don't want to write out the whole sentence. So we'll say, hey, let that hypothesis be P and let the conclusion be Q and let this arrow represent a conditional statement. So if you saw this, the way you would read it would be if P, then Q. That's how you would read that. So we're going to do a couple examples. Can you find the hypothesis and the conclusion of these statements? Wind gusts of 50 miles per hour cause dust storms in the desert. Okay, so which one is our if or hypothesis and which one is our conclusion? Well, this one is causing that to happen. So this would be our hypothesis and this would be our conclusion. The sum of three consecutive odd numbers is always divisible by 3. The sum of three consecutive odd numbers is always divisible by 3. So our hypothesis and our conclusion. The measure of the angles of a triangle's sum to 180. What we could say is if 3 angles of a triangle are added, then the sum is 180. That's how you could say that, but we got a hypothesis and conclusion. Sometimes you have to work it around a little bit because it's not exactly in an if-then statement. But you can change it to an if-then statement. All right, we're going to turn the page. Now we're going to talk about a converse of a statement. So the converse of a statement happens when you switch the hypothesis and conclusion. So let's say they wanted us to use this example of the dog again and write the converse. So remember, P represented the hypothesis before, but it's asking us to do Q first. So we would say if it's a mammal, then it's a dog. What do you think about that statement? If it's a mammal, then it's a dog. The converse happens when you switch the hypothesis and the conclusion. But just because the conditional statement was true doesn't mean that when you switch the hypothesis and conclusion or the converse will be true. Because notice, if it's a mammal, then it's a dog. That is not true. I can think of lots of mammals that are not dogs. So when we switched it the other way, in the original conditional, if it's a dog, then it's a mammal, that was definitely true. But you'll see that it's not now. And that's one of the things that we're going to talk about. Because in geometry, you're going to have a lot of conditionals. But just because the conditional is true doesn't mean its converse will be true. You got to be really careful on that. So let's look at this new set of statements that we're going to make into a conditional. So our hypothesis is going to be Cleo is a cat, and our conclusion is going to be Cleo chases birds. So if you write that as conditional, we're going to say if Cleo is a cat, then Cleo chases birds. All right. Well, is that true or false? Well, I'm assuming Cleo is a cat like most cats, and that's going to be true. Well, let's write the converse. Remember, when we write a converse, we just switch the hypothesis and conclusion. So now our hypothesis becomes Cleo chases birds. So if Cleo chases birds, then Cleo, and I should capitalize that, Cleo is a cat. Okay, if Cleo chases birds, then Cleo is a cat. Well, now this is a little bit different, right? Because we don't know right off the bat if Cleo is a cat. So Cleo could be, the next door neighbor, or Cleo could be a snake. We don't know. So we aren't 100% sure if this is true. Could be false. So we'd have to have a little bit more information. Can you think of an example that proves the converse is false? Yeah, I knew a Cleo once, and he was my boss's husband. So in that case, he didn't chase birds. So it could be false. So I'm going to say Cleo, the husband, right? So there might be a case that makes that whole thing, the whole conditional, false. And if you have something like that, that's called a counterexample. A counterexample is an example of something that makes it false, and you only need one example to prove the whole thing false. So I just proved this conditional false because I know that there's a Cleo that does not chase birds, that does chase birds. Cleo could chase birds, but I got that wrong right there, didn't I? If Cleo chases birds, he's not necessarily a cat. Okay. So you only need one counterexample. So for example, if it is a fish, then it is a trout. Is that true? Well, it could be true for a particular fish, but it's not true for all fish. So I gave a counterexample. Salmon. Salmon is a fish, but it's not a trout. So there's my counterexample. So I've just proven this false. So conditional statements are false if the hypothesis is true, but the conclusion is false. So is it a fish? Yeah, salmon's a fish. Is it a trout? No, it's not. Therefore, that's a counterexample. So whatever my counterexample is, it has to be true for the hypothesis, but false for the conclusion. All right, so we're going to do some examples on page 16. Let's go. We want to know if the following are true or false. If two integers are even, then their sum is even. Well, let's see. Can you pick some? Like 10 plus 10? That's 20. That's still even. 2 plus 2, 4. That's still even. That's true. That's a true statement. There aren't any even numbers that when you add them, you do not get an even number. Okay, so that's true. If you live in the state of Washington, then you live in Reardon. Well, that's not true, right? You could live in Wenatchee. So if you lived in Wenatchee, you would still be in Washington, but you would not live in Reardon. And so because the hypothesis was true and the conclusion was false, that would be false. And what would my counterexample be? It could be any other city. I could put Spokane there, right? I just need one counterexample to prove it false. If there is snow on Monday, then Mrs. Carter will take a nap. What's the hypothesis? Okay, the hypothesis is it snows on Monday. I'm going to call that P and put P there. You're going to write it down when you take your notes. But for the video, I think I'm going to shorten it. What is the conclusion? Mrs. Carter will take a nap. That's my cue. Well, what's the converse? Well, the converse is, I'm going to say it, you can write it. If Mrs. Carter takes a nap, then there is snow on Monday. Okay, well, that may or may not be true, right? Let's try the next one. If there is a football game on Friday, then Jose will wear green. So what's the hypothesis? There is a football game on Friday. That's our hypothesis. What's our conclusion? Jose is going to wear green. What's our converse? Remember, converse is just when you switch the hypothesis and conclusion. I'm going to say it, but you're going to write it. If Jose wears green, then there is a football game on Friday. You can see how if this could be true, but the next one kind of not as much. All right, let's look at this one. If you are 16, then you can drive a car. What's the hypothesis? The hypothesis is if you're 16. The conclusion is you can drive a car. Okay, that's true in some states, right? In some states, if you're 16, you can drive a car. It doesn't say you are driving, it just says you can. But what's the converse? Remember, I'm switching the order. The converse says that if you can drive a car, then you're 16. See how that's not true? So a lot of times this happens. That's why you have to be so careful not to just assume that the converse of something is going to be true, because that's not true, right? I could be 70 years old and drive a car, right? I could drive a car, but I'm not 16. So what you could just say, my mom. My mom is the counterexample. She's, 50 years old. You could say something like that. All right. If it grows apples, then it is a tree. What is the converse? The converse is, if it is a tree, then it grows apples. Well, I've got trees that grow pine cones. So I would write the converse. I would say that it's false, but I would have to give a counterexample, and I would say pine cones. Well, what about a pine tree? A pine tree is a tree, but it does not grow apples. All right. So the next page is what you're going to have for homework, so I won't go there, but hopefully that helped if you missed class. Now you can fill out your notes. I'm Squared, signing out.